In this example, I'd like to sketch the region and find its area. We're going to take a look at the region bounded by this parabola, y equals 6x minus x squared, and y equals 2x. So it's fairly straightforward to show that this parabola will be opening in the downward direction and will have x-intercepts of 0 and 6. Now, if it has x-intercepts of 0 and 6, that means that its vertex is going to be at x equals 3. Plugging in x equals 3 to the given function will give us that y is equal to 9. So I'm going to draw a parabola that passes through 3, 9 as the vertex, and then passes through 6, 0 as well as 0, 0. Now y equals 2x will be a straight line, slope 2, passing through the origin. So something along these lines. So the bounded region that we're talking about is going to be this region right here that is above the line but below the parabola. That also lets me know that our top function is going to be the parabola and the bottom function is going to be the line. Now, with those things in mind, for the bounds, we were not given bounds, so we'll be looking for points of intersection. Intersection, there we go. To find points of intersection, we set these two equal to each other. 6x minus x squared is equal to 2x. Subtracting 2x from both sides will give us 4x minus x squared is equal to 0. And factoring out a common factor of x gives us that x times x minus 4 is equal to 0. This lets me know that the 2 points of intersection will be at x equals 0 and x equals 4. So we kind of already predicted x equals 0, but now we know that there will be a point of intersection at x equals 4 as well. So to set up our region bounded between these two curves, the area is going to be equal to the definite integral from lower bound to upper bound, 0 to 4, of the top curve, 6x minus x squared, minus the bottom curve. Bottom curve in this case would be 2x dx. Integrating this will take little more than the power rule. However, before we integrate, I'd like to combine like terms. 6x minus 2x will give us 4x minus x squared dx. So according to the power rule, this would be equal to 2x squared minus 1/3 x cubed, going from 0 to 4. Plugging in our upper bound of 4 will give us 2 times 4 squared minus 1/3 of 4 cubed. Plugging in our lower bound of 0 will give us 2 times 0 squared minus 1/3 of 0 cubed, which is what I like to refer to as a lot of 0. 32 minus 64 thirds will be equal to 32 thirds. Please feel free to use a calculator if you need to at that last step.